Hey, AP Step babies. Okay, simulation example 2 or example 7 in your notes. All right, this one is fun. You're going to love it. Okay, so a person with blood type O positive blood can receive blood from any other type O donors. About 44% of the U.S. population has type O blood. At a blood drive, how many potential blood donors do you expect to examine in order to get 3 units of type O blood? Design a simulation to answer this question and do 10 trials. All right, so notice, design a simulation to answer the question and do 10 trials. Remember, those are separate from one another. Okay, so let's think about what this is going to look like. Again, I'm going to go through that list in your notes, all right? When describing your simulation, what specific elements do you include? The first thing we're going to talk about, it needs to include what you are using to implement randomization. Well, I am going to, since I have to actually run trials, I'm going to use my random number generator again because it's the easiest thing to use on your video. All right, the next thing, be specific about what each outcome will represent. Well, notice that I've given you that 44% of the U.S. population has type O blood. That means that 56% of people don't have type O blood. I don't care what other type they have, they just don't have type O blood. So I need to let 44% of my numbers represent type O blood and 56% represent not type O blood. So how many numbers should I use? Well, since I'm using my random number generator and I've got 44% here, I need 100 numbers, all right? So I'm going to use 100 numbers, 44 of them will be type O, will represent type O, and 56 will represent not type O. Okay, so the next thing we have to talk about, mention any outcomes that need to be ignored. Well, 100% of our numbers are going to represent someone that has type O blood or not, so there's not really anything I need to ignore at this point. All right, make sure to indicate what to do if an outcome is repeated. Well, I can have 2 people in a row that have type O blood or not, so repeats are totally going to be okay. So repeats are okay. The other thing we need to talk about, indicate when the trial should stop. Well, this one's a little different than the other example we did because notice it says how many potential blood donors do you expect to examine in order to get 3 units of type O blood. So for this one, we are going to stop when we get 3 people who have type O blood. Or actually, I need to change that. Stop when 3 numbers representing type O. Okay, so that's when we're going to stop. And of course, we're going to indicate what results are being recorded. We are recording how many people or how many numbers have to be chosen that represent people. Okay, so how many numbers have to be chosen to get 3 type O? All right, so those are just my notes. So I'm going to write out how I'm going to do this. I'm going to write out my description. So I'm going to say using a random number generator, let 100 numbers represent potential blood donors. One through 44 will represent those Sorry, my handwriting is getting sloppy. I should type these, but I'm not. So 1 through 44 will represent those with type O. And 45 through 100 will represent every other donor. Okay? We will stop when 3 type O blood donor numbers are chosen. Repeats can be counted. And we will count how many total donors we have to check. All right, so that is a little different from the last problem. So again, just like I did on the last problem, I'm going to erase all of my notes over here, and I'm going to use that space to carry out my trials. Okay, so again, these are the directions. All right, they have nothing to do with the trials themselves, how many trials I run. These are the directions for each of the 10 trials. So how am I going to do this? Well, I am going to go back to my random number generator, just like I did on the last problem. And this time I am going to use numbers 1 through 100 to represent 100% of my donors. And I'm going to keep track of how many I have to go through before I get 3 type O blood donors. So I'm going to push generate. Okay, that's a 35. That is a type O blood donor because I'm using 1 through 44 to represent those people. And then I get 59, that is not a type O blood person. Then a 14, that one is. Then a 66, that one is not. Then a 45, that one is not. And then 43, that one is. Okay, so let's go back to my notes here, and I'm going to write those down for you so you'll see what I'm talking about. So for trial 1, I've got 35, 59, 14, 66, 45, and 43. So it took me I got 35, 14, and 43. Those are my 3 type O blood. So I've got 1, 2, 3, 4, 5, 6. So for trial 1, I had to go through 6 total people. I simulated 6 people that I had to go through. Okay, so I'm going to go ahead. I'm not going to show you all the trials because that's going to get tedious. So I'm just going to write down the other results that I got before I showed you this. Trial 5 is 3. Trial 6 is 6. Trial 7 was 7. Trial 8, 4. Trial 9, 6. And trial 10 was 5 people. All right, so that's how many people it took me for each trial until I got 3 people with type O blood. So in order to see on average what this would look like, I'm just going to average all of those together. So let's do that real quick. So I've got 6 plus 14 plus 4 plus 8 plus 3. Yeah, I'm talking to myself again. Well, y'all are listening, so I guess technically I'm not talking to myself. And then I divide that by 10, so I got 6.3. All right, that was what I got. So here's how I'm going to answer this. Based on my simulation, I would need to check between 6 and 7 donors to get 3 with type O blood. Excellent. See how easy that is? Writing the description is the hard part. Carrying out the trials when you're told to carry out trials is really pretty easy. But keep in mind, for this problem, if I had just told you to design a simulation to answer the question and doing the trials wasn't part of it, then you would just have this right here. That would be your total answer, and that is all. Okay, the trials are separate. They're never part of the description because they can change.